Good afternoon, one and all present here. My name is Aritrika Shaha, MTech third semester from Chemical and Polymer Engineering Department. Today I am going to give a presentation on water quality assessment of different samples collected from various locations of Tripura University campus and the selection of appropriate point of use water purification technology. So these are the outlines of my today's presentation. And in before I start, I have to explain that water is required by each and every system of our body, starting from the cells and tissues to various vital organs in order to function properly. So Tripura is still facing the problems of water shortage and the waterborne diseases. Today, the main aim of this project was to the analysis of the water quality of the Tripura University. So the study area of the project was to the various department, not various department, all the departments of Tripura University, and the samples are collected on the month of February 2021. The samples are collected in a clean centrifuge bottle, and the analysis for all the water samples are pH, turbidity, total dissolved solid or TDS, electrical conductivity, chemical oxygen demand, and iron, calcium, and magnesium metallic contents. So these are the samples collected from various locations of Tripura University. All the departments that are, say, let example that the chemical and polymer engineering department. So from each department, we have taken two samples of water. One is your raw water that can be taken from the tap water, and another one is our drinking water. And the drinking water has been taken from the purifier. In maximum department, they have used resin based water purifier, and in some of the departments they have used ROUV based purifier. So these are all the samples, and we have collected 34 samples from various departments, including the two central removal plant. So this is the BIS standard of drinking water. So for TDS, the acceptable limit is 500 ppm. For pH, 6.5 to 8.5 ppm. For the turbidity, it is 1 NTU, and for iron, calcium, and magnesium metallic content, it is zero point 0.3, 75, 30 respectively. So we have taken some the results of the sample analysis. So you can see here 1278, 2 from one department. The row 1 is for raw water, and the row 2 is for the treated water from a single department, and the sample number 7 and sample number 8 from the another department of raw water, and the samples contains the raw water and the drinking water. So here you can see here the electrical conductivity is your 192 micro siemens per centimeter, but after filtration the electrical conductivity reduced to 58.3 microsiemens per centimeter. For all the parameters like total dissolved solid, the first in raw water it is 96 ppm, and after filtration it is 29 ppm, and pH also the same, turbidity also same, iron, calcium, magnesium metallic contents also same, COD same. So these are the comparison between the electrical conductivity and TDS level of raw water and treated water. Here in the x-axis you can see the all the departments of Tripura University, and the blue bar chart represent the raw water, and the red one it is the treated water. You can see here for chemical and polymer engineering department, the raw water, the electrical conductivity and TDS level of raw water is high, but after filtration it is reduced. But if we take an example of botany department, the raw water sample the electrical conductivity is low, but after filtration it is increased. That can be because of the some carbonates and bicarbonates ions are in the pipelines. So this is the comparison between the pH level of raw water and the treated water. And this is same after filtration, the pH level is decreased. But if you take an example of chemistry department, after filtration, the pH of the water is increased. That we can say that the water purifier cannot work properly on this departments. So, yeah, this is the comparison between the turbidity level of raw water and the treated water. In the various departments, you can say the raw water percentage of turbidity is high, and after filtration, it is lower for all the departments. So the filters are work properly for the turbidity parameter. So this is the comparison between the iron, calcium, and magnesium metallic level of raw water and treated water. The blue one, it is your iron content. The red one is your calcium content, and the green one, it is your magnesium content. The first one is raw water and the permeate water for chemical and polymer engineering department, and the second one is the raw water and permeate water for the administrative building. In the here you can see the after filtration, the iron, calcium, and magnesium is content is decreased for the chemical and polymer engineering department. But for the administrative building, you can see here after filtration, the calcium content is high, a little bit high, that we can say the purifier of that administrative building cannot be work properly. So the comparison between the COD level of raw water. So for the chemical and polymer engineering department and the administrative building, after filtration, the COD level is decreased for chemical and polymer engineering department, and the same for the administrative building. So we can conclude that from the present study, it can be concluded that the underground water quality in terms of the turbidity and the pH is bad. And the turbidity for most drinking water samples were in range through the tap water, and the samples were above the permissible limits for drinking. And instead, an UF based purifier with just an UV chamber and the alkaline cartridge is sufficient enough to take care of the point of use based water purification method, in addition to the resin based purifiers. Thank you so much.